Hi everyone, I'm here with your 734 lesson, How Can I Find the Unknowns? Writing algebraic equations and inequalities. Today we'll use variables to represent specific unknown quantities. Then you will use equations to represent real-life situations that involve unknown quantities. You will also explore how equations and inequalities can be solved to determine the values of unknown variables. So let's take a look at 7.1.12. Finding unknown variables with equations. An airplane is at full capacity carrying an unknown number of passengers and 7 crew members. What variable could you use to represent the unknown number of passengers? Write an expression for the total number of people on the plane. An expression does not have an equal sign. For example, x minus 3 is an expression. So we have unknown amount of passengers. So I'm just going to say P equals passengers. So we want to figure out the total number of people on the plane. So we're going to have P plus 7 because we know from our problem that we have 7 crew members. B says, equations can be used to help you find the value of an unknown variable. Equations have expressions on both sides of an equal sign. For example, 9 times the quantity of 2x plus 7 equals 228 is an equation. The plane was designed to hold 241 people. Write an equation that equates the total number of people to your expression in part A above. So we know that we have P plus 7 would equal 241 people on the plane. So again, we have P plus 7 came from part A, 241 people came from our information in part B. C, thinking about the idea of inverse variation operations, determine the value that your variable needs to be in order to solve your equation. That is, how many passengers can fly in the plane. Write a complete sentence. So what we would want to do, inverse operations. So right now we're adding the original number of passengers plus the 7 crew members equals 241. So the inverse of addition is subtraction. So we would need to do 241 minus 7, which would equal 234. So our answer in a sentence is there are 234 passengers on the plane. Okay. Moving on to part D. Whenever it flies, the airplane is not always at full capacity. Using what you wrote in part B as a start, write an inequality to relate the total number of people to the capacity of the plane. In the inequality, use a mathematical symbol for less than or equal to. So it's telling you exactly what inequality symbol to use. So go ahead and try this. If you're back with me, you've tried part D. So hopefully you knew that we had P plus 7, which was from part B, is less than or equal to the total capacity of the plane, which is 241. E says, what values for P will make the inequality you wrote in part D true? That is, what are the solutions to the inequality? So what that's asking is, what number could I substitute in for P that would still make this inequality true? Well, all whole numbers between 0 and 234 would make this inequality true. So I could do 5 plus 7, okay, that's still less than 224. I could do 10 plus 7, 17, 17 is less than 224. I could do 234. 234 plus 7 would give us is less than or equal to 241, so it would be equal to 241. Okay, so we're going to do a little bit more work with these inequalities. Looking at 713. 713 says, according to the attendance office, Lakeside Middle School has 57 fewer students than Xavier Middle School. You want to determine the number of students that attend Xavier Middle School. A, when you use a variable to represent an unknown, you will need to define your variable using a let statement to communicate with your variable what your variable represents. For example, in problem 7.1.12, you could have said let P represent the number of passengers. Write an algebraic expression for the number of students at Lakeside Middle School. Make sure you define the variable you choose. So let's use x. So let x represent the number of students at Xavier Middle School. Okay, so we're going to write our expression together. So x is how many students Xavier Middle School have, but we know that Lakeside has 57 fewer students. So what operation are you going to need to represent fewer? Hopefully you said subtraction. So x minus 57 will give you your expression here. Moving on to B. It says the attendance office says there are 403 students at Lakeside Middle School. Use the expression that you wrote in part A and write an equation for the number of students at Lakeside Middle School. So go ahead and try and write your equation. Okay, if you're back with me, you wrote your equation. So x minus 57 would equal the total number of students, which is 403. C, how many students are at Xavier Middle School? Explain how you used inverses to find your answer. Write your answer in a complete sentence. So go ahead and try and do part C. Okay, if you're back with me, you tried part C. So we would do inverses. So you would undo the subtraction by completing addition. So 403 plus 57. That would be 10, 6, 4. So there would be 460 students at Xavier Middle School. We undid the subtraction with the inverse operation of addition. Okay. C says, use your equation to show that you know that 550 is not the number of students who are at Xavier Middle School. Test two other values that do not make the equation true. How many solutions are there to the equation that you wrote in part B? So, let me help you with this. So we're going to start with 550 minus 57 equals 403. So 550 minus 57 3 9 and 4. So that would give us 493 equals 403. That is a false statement, so it's not true. I would like you to try, as your other two numbers, I would like you to try 520 and 475. Okay, so go ahead and try these. These are going to be two things that we saved to talk about in class, but I want you to show me by substituting in these values that it's not going to make the equation true. So go ahead and do that. Okay, if you're back with me, you finished part D in that problem. We're going to move on to 7.116 right now. Alrighty. So 7.116 says solutions to a linear inequality. Moqui is studying for his Spanish and history final exams. He knows that he needs to spend more time studying for Spanish than history. He decides he will spend half an hour more studying Spanish than history. Let H represent the amount of time Moqui spends studying history. Write an expression using H that represents the amount of time he spends studying Spanish. So we have let H represent the amount of time Moqui spends studying history. So we already have our let statement right there. But we need to write an expression using H that represents the amount of time he spends studying Spanish. So we have H, because that's what he spends for history. And up here it says he will spend a half hour more. So we're going to write it as a decimal. Plus 5/10. Okay, and that is our expression here. Moving on to B. Moqui spends more than 2 hours and 15 minutes studying for Spanish. How does this amount of time compare to the expression you wrote in part A? Write an inequality to represent this situation. Well, 2 hours and 15 minutes, when we convert that into a decimal, is 2 hours, 2 and 25 hundredths. So we know he wants to spend more than that. So H plus our 5/10 is going to be greater than 2 and 25 hundredths. Okay, we're going to actually skip over part C. And we're actually going to skip over part D. Okay, I just wanted you to get some practice writing. So, real fast, if we're looking at 7.1.17, it's talking about graphing. So when we graph boundaries, when we graph inequalities, we have boundary points. So if you look at part D, it says, is the boundary point for this problem of the set of solutions to be included on the number line? If the boundary point is part of the set of solutions, then it would be represented as a filled in dot, just like the rest of the solution. If, however, the boundary point is not part of the set of solutions, then how might you represent it on the number line? So we're going to talk about this. Looking back at problem 7.1.12, we talked about in part D that P plus 7 is less than or equal to 241. So this does not go along with this question, but I do want to show you this. P plus 7 is less than 241. So if I said my answer to this would be 234, when you graph an inequality, I'm going to just say 234, 236, this will be 232, etc. So less than or equal to means you are filling in the dot above your solution. And whatever way the inequality is going is the way your arrow is going. So when we graph this, this is representing that 234 or any number less than 234 makes the inequality true. However, if we had, let's go back to Moqui, if he needed to study greater than an hour and 45 minutes, okay, I'm just using that as an example, we would have our graph. Hour and 15, hour and a half, hour and 75, or hour and 45 minutes. That's 2. Okay. What this means is to make this inequality true, he would need to study more than 1 hour and 45 minutes, which is 1.75 or 1 and 75 hundredths hours. than that. So our boundary point is now open because 1 and 75/100 is not an answer. We cannot have that as an answer, but we still need to graph it as an open boundary point, and our arrow here is pointing to the right because our inequality is greater than. So what this is telling me is that any number after 1 and 75/100 would make this inequality true. Okay? So you don't have to do anything else there. That's just some graphing that I wanted to go over with you that is important. Okay, we're going to move on to 7.118 now. So 7.118. Each April, bluebonnet wildflowers are commonly seen throughout Texas. One botanist claimed the number of acres of bluebonnet wildflowers in Gillespie County this year could be estimated by the inequality W minus 30 is greater than or equal to 110. The variable W represents the number of acres bluebonnet wildflowers. A. Some local residents guessed that there would be 100 and 25/100, 126, 140, 152 and 8/10, or 163.5 acres with bluebonnets in the county. Test these values to find out which of them are possible for the acres of wildflowers this year. So we're going to check it out. I'm going to do the first one with you. So 100, 25/100 minus 30 would be 70 and 25/100 is greater than 110. Is this true? No, this would be false. So you know that this is not an answer. So now you're going to try it again. 126 minus 30 is greater than 110. I would like you to finish part A by trying out the answers 126, 140, 152 and 8/10, and 163.5 acres. Go ahead and try that. Okay, we're going to save this to talk about it, but I am hoping that you saw 140, 152 and 8/10, and 163.5 acres would be your three answers that would make this inequality true. B says, write an inequality to show all of the possible values for W. Well, we know that W needs to be greater than or equal to our lowest number here, which is 140. So W is greater than or equal to 140 is going to be your inequality. So C says, show all possible numbers of acres of bluebonnets on a number line. So we're going to start here. Ooh, it's not very straight. And let's just do 0, 40, 80, 120, 160, etc. Go ahead and try and graph this. Okay, if you're back with me, then you should try to graph it. So we're at 140, and our boundary point is shaded in because W is greater than or equal to 140. So shaded in boundary point, and our arrow is going to the right. That's telling us that any 140 or any number greater than that makes this inequality true. Okay, finally, if you look at 7.120, 7.120 has some great practice problems. We have some inequalities and we have some equations. Remember, inverse operations. So it also wants you to show the solutions on a number line. So when you are just graphing the solution to an equation on a number line, all it's going to be is a point. So let's say the answer here, okay? So let's say the answer here is 30, which I'm not saying is true, but you would just make your number line and plot a point. That's how you would do it. For an inequality, though, remember, you're going to have your boundary point, Okay, could be greater than, could be less than. I'm just showing you all your options. Could be greater than or equal to, or it could be less than or equal to. Okay, so these are your options when you are graphing inequalities. When you're graphing an equation, it's just going to be a point on a number line. A, B, C, and D, A, B, C, D, and E, there's actually 2 C's, whoopsies. I would like you to try these, try graphing them. This is going to be something that we save to talk about in class. As always, if you have any questions, please email me. And when you are done, please make sure that you upload your pictures to Google Classroom.